So in this example, we're using the rational root theorem in some context. So we have a function volume of the storage unit, and we know that the volume is 154 cubic feet. So what we can do is set the expression for the volume set equal to the volume. In order to find the zeros, though, you're just going to subtract that 154 over to the other side to set the equation now equal to 0. The constant was negative 154, so we list out all the factors of those. The leading coefficient was 2, so we list out the factors of those. So taking out, well, it's all of those divided by all of those, right? So you're going to get all your possible rational roots. They're suggesting to use a spreadsheet or a calculator to test all the values. You can do that. What I'm going to do when we do the next example together is, once I have my possible rational roots, I'm going to graph it and then cross-reference, see if I'm seeing a 0 on the graph. That is one of my possible rational roots, and then I'll know that that's the one I should be testing. In this case, they're showing that on their spreadsheet, 11 halves worked. Again, you can set up a spreadsheet if you want to do it that way. But 11 halves worked. So then they're going to do synthetic division with negative 11 halves as the, actually, no. It says 11 halves here. When you actually look at the work, there should not be a negative sign there. That's a typo because they dropped the 2, and then 11 halves times 2 would be positive 11. So that's positive 11 halves there. Anyway, what they have left over is 2x squared plus 4x plus 28. Using quadratic formula on the quadratic part that's left, you're getting a discriminant that's negative, meaning that the zeros associated with that would be imaginary. So 11 halves is the only one. So that means the width is 11 halves. And then if you go back and work out the, I guess there's expressions given in the picture there, but you just substitute the 5.5 or 11 halves in to get the length, which is 3.5, and the height, which is 8. All right, so let's check out the you try it question. Basically the same kind of question with a jewelry box, all right? So you have the dimensions and you have the volume. So it's giving you the function for the volume, so you don't need to actually multiply that together to get it. And then it says the volume is 28, so we're going to set that equal to 28. Find the zeros, so find the possible rational roots. I'm going to graph it. You can try to figure out which of the possible rational roots is a rational root, whichever way you prefer, and then you'll have to do synthetic division with what's left over and all that. So give that all a try. So pause it, give all that a try, and then come back and check out my answer.